Hello, everyone, and welcome to today's webinar, The Tactical and Practical Guide to Flowable Navel Orangeworm Mating Disruption, sponsored by Suterra. I'm Robin Sittberg of Meister Media Worldwide, publisher of American Western Fruit Grower magazine. In this webinar today, our speakers will talk about mating disruption of the navel orangeworm and a new flowable mating disruption product that's available in California and Arizona. They'll explore the economics of flowable mating disruption at different spray frequencies, the philosophies behind different spray timings, and share practices for safe handling, labor-saving deployment, and greatest efficacy. We'll have time for some questions at the end of the webinar. If at any time during the presentation you'd like to ask a question, type it in the question pane at the lower left panel of your screen and click Submit. You can do this at any time during the webinar, and we'll answer questions at the end. This webinar has been approved for 1 credit from CDPR. To receive credit, you must watch the entire webinar, including the Q&A portion. Please submit your name for credit to CDPR after the webinar. Our first speaker is Joan Wickham. She is an entomologist. Oh my goodness, I just can't believe oh, here we go. I'm sorry. Joan Wickham is market strategist at Suterra. And at Suterra, she now gets to focus on what she's most passionate about, which is helping growers protect their livelihood. In her role, Joan works with growers and PCAs to understand opportunities for Suterra to better serve its customers by understanding market dynamics. So I'm going to let Joan get started, and she'll go ahead and introduce the other speakers for you. So take it away, Joan.
Thank you so much, Robin, and hello, everyone. It's my pleasure to welcome you to our session on new mating disruption control options for navel orangeworm. Today's session will be led by 2 highly accomplished members of Suterra's technical field team, Emily Symmes and Greg Montez. But before we dive into their presentation, I just wanted to give you a brief overview on who Suterra is. We are the global leader in sustainable pest control. We're headquartered in Bend, Oregon, where we actually have the only dedicated pheromone manufacturing facility in the world, which is pictured here in this slide. And we're fully integrated, so that means that we handle everything in that facility from early stage research and formulation to product design and manufacturing. And the reason that matters to you is that it means that we're able to deliver consistent quality products that you can trust, so consistent chemistry and reliable hardware. And just as important, in California, we have a dedicated technical team of experts like Emily and Greg to support growers and PCAs and also gather the insights that lead our innovation efforts in Bend. This team is so important to us at Suterra because solving problems for growers is really our singular focus and passion. And that, of course, means spending time in the field and engaging with all of you and on webinars like today. So with that, I would like to introduce our 2 speakers, Emily Symmes and Greg Montez. Emily is a native of Northern California, and she's been working in agricultural pest management since she was a teenager. During that time, she discovered her passion for applied entomology and integrated pest management, and she went on to earn her bachelor's, master's, and PhD degrees in entomology from the University of California in Riverside and Davis. Prior to joining Suterra, Emily served as the UC Cooperative Extension Area IPM Advisor in the Sacramento Valley and as Associate Director of Agriculture for the statewide IPM program for over 5 years. Greg Montez was an accomplished entomologist who started his academic career at Fresno State before spending 20 years as a research associate at the University of California's Kearney Agricultural Research Center with a specialty in insect pest management. In the private sector, Montez most recently worked as an entomologist with an emphasis on pheromone pest control. In addition to Emily and Greg, our 2 speakers today, we also have our broader technical team present on this webinar, Mondo Perez, Sarah Goldman, and Melissa O'Neill. As I said, this team is really passionate about working with growers, and they're looking forward to engaging with you during this session and beyond. Just one administrative note before we move into the presentation. We just want to mention that this presentation is not a recommendation, so please make sure that you consult with your PCA to determine the best practices for your operation, and also, of course, adhere to regulations on pesticide labels. And with that, I'll turn it over to Emily Symmes.
Thanks, Joe, and thanks everyone for joining us. What I'd like to do is start by addressing the current navel orangeworm situation in California and talk about a number of different factors that are really combining to make this pest an increasing challenge with regard to management, and one that is necessarily taking additional inputs to accomplish our desired damage and production levels. And what you're looking at here is just a map with the three primary agricultural host crops overlaid, pistachios shown in green, walnut in blue, and almond in brown in that map. And I like to show this and just talk about the idea that really the Central Valley is a bit of a buffet just in terms of these three nut crops when it comes to navel orangeworm resources, both in a landscape scale manner, as we have a lot of contiguous or acreage in close proximity to one another, and then really from the bottom of the Central Valley all the way up to the top of the Central Valley in the Sacramento Valley. And the numbers show that our bearing acreage is increasing in the nut crops over the last decade. And when I ran these numbers from 2010 to 2018, the bearing acreage increase was 50%. And so we add an additional 2 years, and what we see is that bearing acreage is up 75% just among these three preferred nut crop hosts. And what's not shown here is that navel orangeworm actually has very wide host range. So it's able to utilize both other agricultural crops as well as native plants in the environment to survive and reproduce, and then ultimately potentially impact our cropping systems. Additionally, the situation, we talked about resource availability, we can talk about that in terms of temporally or over time, where we know that navel orangeworm overwinters in any of the crop residue or mummies left behind in the orchard, and those early generations, the early generation really relies on those mummies or crop residues left behind. But then as we progress through the in-season, we have this staggered crop phenology among these nut crops where the almond start to split, and then the pistachio, and then the walnut. And essentially what you've got is new crop hosts anywhere from the end of June all the way through October, which allows for population development, reproduction, and movement around the environment. So we really have a situation where navel orangeworm has year-round resources just among the three nut crops in the system. Another situation has to do with navel orangeworm phenology, or really the seasonal cycle over the year. What you're looking at here is a representation of a hypothetical almond development model where we utilized a standardized, what is a typical maybe observation period of an egg trap biofix, standardized to show the differences in development over the years. And what we see is that there's been a fairly dramatic shift from 2012 through current, with increasing heat units throughout the growing season, which ultimately results in faster generation timing, earlier flights, and an increased susceptibility period of when the in-season crop, whole split, through harvest is most susceptible. What we also see here is that these data are taken from Colusa County. This is in the Sacramento Valley. And what this represents also, if you get to the fourth generation there, is that 4 generations are increasingly common statewide. And this is really important. Years ago, a few decades ago, a 4th generation was relatively rare, at least in the Sacramento Valley. It was more common to see that in Kern County in the southern San Joaquin Valley. And this demonstrates that shift in not only we have an additional population with moths flying around, certainly when our pollinizers are still on the trees, but this is an added population increase potential. And we'll look at some of those numbers of what the potential population increase into that 4th generation is. And similarly, you can look at this. The data that I pulled here is very similar to the last image, but just shown in a bit of a different graphic. And those light green dots over toward the right side of your screen, those represent 2010 and 2011 in terms of when navel orangeworm degree day model from January 1, for example, hit these different flight timings. And you can see how dramatically those have shifted into earlier in the season. What else do we know about navel orangeworm? It's obviously a huge challenge and a lot of ecological and biological factors that make it a key pest in the system. We know that females have a high reproductive capacity. Typically, we use calculations or estimates of 80 to 100 eggs per female, but they can lay significantly more eggs than that per female, up to 180, 200. We know that multiple larvae can develop in any individual nut, and we've got, I've taken harvest samples where there are 12 larvae in an individual nut all surviving. What this amounts to is extreme population buildup when our in-season nuts are most vulnerable, so that whole split through harvest period. In addition, it's important to note that navel orangeworm is an absolute scavenger in the environment too, so it doesn't rely strictly on these nut crop hosts to reproduce at these specific levels. So let's look at a model of population growth potential. What's shown here is first, second, and third generation population growth potential. And there's some very basic model assumptions here. This is an almond system with an average 124 trees per acre. The numbers that I ran here are a moderate sanitation to 6 mummies per tree, assumption of an overwintering infestation of 2% or 1 larva per nut at that infest, and females laying 80 eggs each. And we're also including here a 50% mortality each generation. And what that really is probably just a baseline level of mortality, because this is ecologically an R-selected species, so we know not all offspring survive just because of natural factors. So what we can see is a 1,900% increase in each given generation. And generation 3 really is we start getting into almonds in generation 2 at whole split. Generation 3 is what we're trying to avoid, certainly with timely harvest and our nonpareils. And then if you add generation 4, where we might have our pollinizers still in the environment, you see that dramatic increase in population potential simply because of the fecundity rates of the individuals. And when you're looking at these numbers, this is when you start thinking about your pest management program. So you start thinking, okay, this is a model assumption. What can I do to further cut any of these numbers? So can I add additional sanitation inputs and drive that number down? It's a very simple calculation. You can plug and play with these numbers. If I can get my mummy infest down or my mummies per tree down, that kind of starts the generation 1 baseline at a lower level. Then we looked at fertility rates. So females have the capacity, for example, to lay 80 to 200 eggs per female, but with a practice like mating disruption, what we're driving down is fertility, or the success of actual mating and laying those viable eggs in the environment. And then how do we increase mortality? And that's where things like an insecticide program comes in. So we know the type of damage that navel orangeworm causes, and it's a direct pest, which means it's a worm in the product that we're selling for folks to eat. And that's different than an indirect pest, like something like a spider mite, where certainly can have quality impacts, yield impacts the following season. Direct pests are often have much lower tolerance for damage. As well, we've got the situation with navel orangeworm infestation coexisting with aflatoxin contamination. So we have necessarily incredibly low damage tolerance in our nut crop industries. Let's look at some potential losses given current production estimates and recent production across the nut crops. So crop forecasts suggest that almonds will produce a 3 billion pound crop this year. At 2% average loss, you're looking at $105 million in losses just from navel orangeworm, just one single pest in the environment in the system. With the pistachio estimate, they're looking at if 2% was the statewide average, a $60 million loss. And with walnuts, a $26 million loss. And according to a recent video interview with Bob Klein of the Pistachio Research Board, he estimated that the collective total cost estimates between losses and all of the management input costs to manage navel orangeworm collectively across these 3 industries is about $800 million annually. So that really summarizes the bad news, but the good news is for navel orangeworm, and this can't be said for all of the pests that impact our agricultural environments, we do have fairly robust integrated pest management strategies, approaches, and tactics available. And you're all very familiar with these kind of primary 4 pillars: So we've got sanitation, where the goal is to reduce the overwintering population and reduce those early generation resources to limit the amount of pressure that's overwintering and the amount of buildup that's leading into the second, third, and fourth generations. Then we've got mating disruption. We have puffers, flowable, and dispensers. These are all the available platforms for navel orangeworm. We've got insecticides, and while there are a handful of different insecticide modes of action, really right now, industry-wide, we're really reliant on 3 primary modes of action. The diamides or group 28s, IGRs, a lot of those are the group 18s, and then the pyrethroids or the IRAC 3As. And then we come in with the need to have an effective, timely harvest. We want to be cautious not to say early harvest here, because the crop still needs to be in an adequate harvestable state. But ideally, we get the harvest done and get the nuts dried and out of the field as soon as possible to avoid those big later generation pressure periods and shorten the susceptibility window. So with that, so the available mating disruption platforms for navel orangeworm, again, right now they're on the market, commercially available. We've got puffers, which is the aerosol-based approach. These go out at a rate of 1 per acre. They release pheromones nightly during the active period, mating period for navel orangeworm. These last all season, or 8+ months, and currently at a cost of $105 per acre. Flowable is what we're really going to highlight for the rest of this conversation today. This is considered what we call a continuous release product. So it releases 24/7. Current suggested rate is 3 ounces per acre. Can last up to 30 days within a cost per application per acre of $29. And then there are dispensers also on the market. These go out at a rate of 15 to 28 per acre. These are hand applied. The release is similar to the flowable molecule, so to speak. These also last season long, and current market is roughly $110 to $140 per acre. So these are all available for you to consider in your program and think about things like labor savings with lower rates per acre, and what your system really calls for. Does it call for puffers? Does it call for flowable? Does it call for a combination of approaches with regard to mating disruption? And with that, I will pass to Greg, and he's going to talk to you in detail about these sprayable formulations.
Well, hello there, everybody. This is Greg Montez. I hope I'm coming across well so that you can hear. The pheromone chemistries have been around for quite a while. I can go back to the first time I encountered them would have been 1983 at Fresno State, as when I was an undergrad. And the sprayable mating disruption technology is many decades old. We've had the first sprayable pheromone with gossip lure for pink bollworm. That was back in 1989. Suterra's first attempt at this, or first marketable product, was for tomato pinworm, and that was 25 years ago. So we've had a lot of experience making this type of a product. But navel orangeworm is a more recent development, and it's taken some engineering to get that going. Okay, so now Suterra has got 9 different insects that we are developing, or we have developed sprayable mating disruption for. And we have more on the way. Each of these insects requires or has a distinct chemistry, and each product is its own distinct engineering feat. We thoroughly test these in the laboratory and out in the field before we release them. And at this point, Suterra has the only navel orangeworm pheromone sprayable form on the market. So what exactly is a mech? The pheromones are very fragile molecules, and they require a lot of special handling for whatever we choose, or however we choose to get them out into the field. The insects themselves, they create pheromone on the fly. They create and release it, and it just doesn't last very long at all in the environment. It's not expected to. In a puffer, the pheromone's all sealed up and protected in a steel can. But to make a sprayable formulation, we still have to have that protection around the pheromone molecule, but in a way that allows it to get out into the plant surfaces and be useful, but still be protected. The process of doing that is called microencapsulation, and the finished product is a capsule suspension. Otherwise, it's the same active ingredient. The pheromone is the pheromone for all insects of the species. So the active molecule here is hexadecadienyl, and that's going to be the same for anybody's product, any way it's released. So these capsules, they're holding the pheromone molecules inside, and that keeps them from degrading until they pass through and they're released out into the air to do their job. The capsule itself is an amazing piece of engineering because it has to contain and protect the pheromone, but at the same time, allow it to escape at a constant, steady rate. It's a very, very delicate balance between making the capsule small enough to spray out of conventional spraying equipment and sturdy enough to last out in the environment for a useful period of time, but permeable enough to actually release the molecules. If we didn't make these capsules, if we just released pheromone straight out of the jug into the sprayer out into the environment, it would just disperse and it wouldn't last very long at all. It would break down in hours. So a bottle of MEC or MEC has just billions, quadrillions of little tiny dispensers that go out and they do their job, they do their thing. A little bit about what mating disruption does and what it doesn't do. So we have adult insect pests out in the field, and the females are creating and they're releasing their amounts of pheromone for the males to pick up on, get attracted to, and eventually find a mate with the females. So the insect itself has a very delicate balance because the female only has a very limited amount of energy to expend. She's got lots of things to get done in her life, respiration, making eggs, making pheromones, flying. All those are a drain on her energy resources, and navel orangeworms don't feed once they become adults. All their energy comes from when they were larvae and surviving through the pupal stage. So she just has enough energy to do what she needs to do, and then they pass on. But enough pheromone has to get released into the environment to make it all work. Part of this is that the female navel orangeworm has adapted to releasing pheromone only at certain times of the 24-hour cycle. That would be in the evening hours. The other part of that is the male has just become super sensitive to the pheromone molecule itself. So the goal of mating disruption is to flood the area that the crop is being grown in with enough pheromone to mask what all of the female insects are making. What we accomplish by doing that, by masking this area, are three things. If the female cannot mate before she uses up all of her metabolic energy, then there's no forward generation. Her eggs are non-viable. If the female has to wait a long time before a male comes along, she's exhausted a great amount of her energy that she doesn't get back. So those eggs, even if she does mate, are going to be fewer and less viable. And that the third goal here is that navel orangeworm have the ability to mate multiple times. If we can block that, we're also reducing the number of viable eggs that are produced. And all of this adds up to fewer worms to injure the crop. So that is what mating disruption does. what it does not do is this is not an insecticide. Bugs will not fall out of the trees by putting on a mating disruption pheromone. It will not interfere with navel orangeworm eggs or larvae that are already out there, already active in the crop. Okay, if that's already happened, the pheromone won't do much to affect them. The pheromone mating disruptor also has no effect on any other insect or any other organism that happens to be out there. So I get this comment a lot, your pheromone will attract every bug in the county to my orchard. I don't want your pheromone. That's just not the way it works, for a couple of reasons. There are insects, codling moth, for example, that use just one molecule for pheromone, and the mating disruption and the lures use that one molecule also, but in such high doses that the male insects just really don't have any idea which direction to fly in. Okay? Navel orangeworm is different in that the female doesn't make just one molecule, but actually 4 of them. All 4 molecules in the right proportions and in the same dispenser, you would call that a lure. For navel orangeworm mating disruption, however, we just use one of those 4 molecules, which is enough to achieve our goal to mess with the male navel orangeworm's directional finding apparatus. But the advantages of just using the one molecule are that it drives the cost of the product down. It's tremendously less expensive to make. And the engineering for the microcap gets a lot easier, not dealing with 4 different sized, different weighted molecules. You just have the one to worry about. And so that engineering gets a lot less complicated, and the product still works great. However, having said that, the pheromone is not a repellent either. If there are orchards in a neighborhood where you've got places that navel orangeworm are free to roam, like if there's an unmanaged almond block or pistachio block in the neighborhood, there's really nothing to prevent a mated female from picking up and riding the wind and moving into your otherwise protected block. Having responsible neighbors, having clean neighbors, having a large-scale area-wide suppression program, if you will, is a great way to keep these. It's the best way to get these things under control. The other thing you're not going to have to worry about using a pheromone for mating disruption is chemical residue. Pheromones are considered non-toxic to humans and every other life form. So there are really no worries about residues, and you're clear to spray or to be using mating disruption pheromones up to the day of harvest and beyond. One of the things we absolutely do want you to be doing is filling in your use reports. That's good information for us, and it's the law for these products, for all agricultural chemicals. So please be filling in your use reports. Navel orangeworm management can be very different from place to place and from time to time and from year to year, like Emily just mentioned. The grower PCA relationship is critical because having eyes out in the blocks, having eyes out in the field will help the knowledge flow and making timely decisions based on accurate data. And no IPM tool will ever do all of the work for you. The different tactics all complement each other. For the growers that use navel orangeworm Flowable, it applies just like an insecticide as compared to a puffer or a dispenser. And there are some advantages to that as well as some issues to be aware of. It is a truth that mating disruption doesn't need to be area-wide to be effective, but generally, the larger the area, the better it will work. Along those same lines, once you've got your damage under control, once you've got it down where the percentage of worm infestation is acceptable, and that percentage can vary from grower to grower. You just want to keep on top of it. You want to keep the worms under control, make sure they don't come back. Because if you get slack with the control, they will come back. And we're seeing that happen in some other cropping systems. We're seeing where maybe the foot came off the gas a little too early and the pests are coming back. So the product really is not an insecticide. The labeled uses are for nut crops, walnuts, almonds, pistachios. It's labeled for figs. I believe it is labeled for pomegranates. So well, I'll have to refer to the label to get you the entire scope, but pretty much any crop that has navel orangeworm as a pest, this should be okay to use on. Let me get back to you on that. So the benefits of navel orangeworm flowable. It's been pretty generally proven that adding the mating disruption to an existing program cuts the worm damage at the end of the season by at least half, and typically more than that. And here in 2019, the season we're just coming out of, we applied 100,000 acres of almonds and pistachios with navel orangeworm flowable and had great results. With this particular almond trial, we found that when the grower, comparing to what the grower normally would have done and adding navel orangeworm flowable to that, we drastically reduced the damage that the grower realized. In the pistachios, the graph off to my right, the grower was already doing a pretty good job with limiting their navel orangeworm, but by adding the flowable, we drove that damage down even more. So with these two graphs, the control is not nothing. The control is the grower standard, what the grower's insecticide program would have been anyway. Adding the navel orangeworm flowable to that realizes the decrease in damage. So other benefits with this. When you're deciding to incorporate navel orangeworm flowable pheromone into your navel orangeworm program, there's some things that you might want to consider. Remember that this is not an insecticide. You'll want to have this out doing its job before the flight starts. So you'll want to be really proactive, monitoring the degree days, having your egg traps out, having your pheromone traps out, stay up in communications with your PCA so that you can get this out in the orchard before the flight begins. But you'll have the option of adding navel orangeworm flowable to the tank if the timing is right and you're going through anyway with a nutritional or a fungicide or another insecticide. It's mixable with all three of those. If your property has a history of low damage, except for one problem corner, one problem area, the east side of your orchard tends to get navel orangeworm, you can use flowable in just that portion of the block, and you can even apply it by air. It works fine, works great. If you've got young trees are difficult to hang puffers in, but they can still harbor a lot of navel orangeworm. And also, looking at a contoured block, a block with odd borders, that might not be a good fit for puffers. Navel orangeworm flowable can provide much better coverage of irregular shaped blocks and works great with young trees. I just want to remind you that navel orangeworm will not keep mated female moths out, but if you've got a neighbor that's generating a lot of moths, unmated females entering the block will be affected in the same way that the population that's already there would be, that the males will not be able to find them. So other benefits of using the Flowable. With regard to insecticide resistance, this is a very real problem with navel orangeworm. It's been documented by researchers, it's been documented by PCAs, not getting the results that they were used to expecting from some of the chemistries. And there's so few chemistries permitted to be used anymore, and we've completely lost the broad spectrum organophosphates of the 70s and 80s and 90s. So keeping insecticide resistance from developing is seriously important. Got to keep what's working, what we have, for as long as possible, and mating disruption will help with that. We're keeping the gene pool scrambled. We're reducing the population further than with the insecticide alone. Those are things that will help stall the development of resistance to the chemicals we have. And since we're using the insect's own communication system against them, there's no real problem with the insects becoming resistant to mating disruption. It's using their own chemistry against them that they've taken millions of years to develop. So resistance to the pheromone itself is not going to happen. One of the other benefits to the mating disruption sprayable is that it's so specific to to one insect only. There's not going to be any issue with bees or beneficial insects that are out working in the orchard. That's good news for predators like our friend here, the six-spotted thrips, who is happily munching on spider mite eggs. So we've already mentioned that you can make a tank mix with navel orangeworm flowable and other materials, the nutritionals, the fungicides, other insecticides. And we'll be talking about compatibility with some of the other chemistries in just a bit. You're going to have researchers and farm advisors, they'll point out that spray coverage is a serious reason why an insecticide is not performing like it should. And with the pheromone, you're not looking at for the insect to eat or crawl over the chemical. In order to make it work, it's out in the air doing what it does. You can have your applicator go at a faster tractor speed if they're playing just the Flowable by itself, and you can fly it on. You can use an ultra low volume. All of that's good. So this is a table of conventional insecticides versus navel orangeworm flowable. Your reentry period for flowable is when the spray is dry. That's the minimum that DPR will allow. Your pre-harvest interval is serious information. Conventional insecticide, you can't pick up the crop until 14 days have passed. You've got a 0 pre-harvest interval with navel orangeworm flowable. You're going to have a duration, a field life of up to 30 days. Like we mentioned before, there is no residue levels, nothing to worry about, but you do need to have a recommendation written. The price per acre is right in line with the other conventional insecticides. So we have a deployment guide. You can find details on volume and recommendations as to spray on the label and in the deployment guide. It is formulated to not require adjuvants. You can use spreader stickers, but we're asking at this time to not use the organosilicone class of spreaders. Sometimes they'll not play nice with the microcap technology. You might need to reapply if there's rainfall. Of course, rainfall in June in Central California, or rainfall in July, is not very common, but it can happen. If it rains, you might consider reapplying. It's possible in the bottle for the microcaps to float to the top and create a crust. That needs to be broken up. So shake the bottle vigorously, bang it against the hard surface, get everything in there really good and mixed up before adding it to the tank. And don't let it sit once it's in the tank. Keep it agitated, keep it moving, and start applying immediately. So spray timings. This is not to suggest that we want you to be doing all of these. These are the vulnerable periods in the navel orangeworm life cycle that one can deploy a control measure. You've got your winter sanitation in December through March. You've got your puffers go up March through April. Excuse me. The spring spray, the May spray, that's coming on in May, late April, early May. And you've got your whole split sprays, which are the primary targets, primary weapon opportunities to get the best navel orangeworm control would be the whole split sprays. And then if you've got a really late pollinizer, you might need to apply there also. For pistachios, there are some additional moments of vulnerability to for control for navel orangeworm. Again, mating disruption, sanitation is key. The mating disruption, you get that on for the puffers for late March, early April, but then you have other windows of opportunity to get Flowable into the mix. And these are some of those opportunities. The orange bars are for almonds, and the green bars are for pistachios. And we do find that if your navel orangeworm budget for almonds has room for only one Flowable application, it's best applied mid-June through mid-July for almonds. And that timing is nearly upon us. For pistachios, if you're just using the one application, then it's best to wait until the nuts are just ready to split, and that would be mid-August. 2 applications will get an almond grower through from mid-June through mid-August with that 30-day activity. And you can see that we do have recommendations for 3 and 4 applications, and that pretty well covers the whole season for pistachios and almonds. But at that level of activity, at that price point, you may want to consider, instead of the Flowables, going to a puffer, a season-long option, maybe more economical at that point. And I'm going to pass the ball back to Emily. Take it away.
Thanks, Greg. So I'd like to talk a little bit about the kind of the economics and different programs and return on investment models. What you're looking at here is a few selected NOW damage percents. The premium schedule was provided by Blue Diamond. The assumption here is a base value of $1.75 a pound and yield of 2,500 pounds per acre. With the almond schedules, you can see that there's essentially three damage percent lines there. And what the assumption is that for every percent damage NOW on your grade sheet, the assumption is that you've left the equivalent percent out in the field, because the damaged nuts, the infested nuts, can be a little bit lighter, so they get blown out. Great news, it doesn't end up on your grade sheet, but it still is accounted for in terms of your yield loss, essentially. So what you're looking at here is anywhere from, bringing in a completely clean with regard to NOW rejects crop all the way up to 10%. You can see the incremental decreases in crop value and the losses as you move up, not just in base value, but also with regard to losses in your premium schedule, where when you get down to the 10% level, essentially you're almost paying the processor to handle your load there at that level. A similar quality bonus schedule provided by Wonderful Pistachio for our use goes through basically the same exercise here for percent NOW damage. The increments here are smaller. The total maximum is smaller. This represents an on year, for example, in terms of pounds per acre. So if you were looking at an off year, you might look at this calculation and replace it with 2,000 pounds per acre, 2,500 pounds per acre. You can see the losses where once you get essentially 1% and above, that's when you're starting to lose your quality bonuses. So the goal here, the industry say join the less than 1% club or the 1% club, and that really is the goal when it comes to maximizing not only your yield, but all of these quality bonuses as well. So let's look at a couple of hypothetical use case scenarios. And again, I like to consider these sort of plug and play exercises where you can look at your particular operation, you can look at what level of NOW management inputs you put in, what costs were associated with those, and then ultimately what your damage percent was at the end of the season and what your returns per acre were, and look at, did my program pay? Did it get me to that damage level that I really wanted? I think when it comes to IPM, a lot of times we're very in the moment with regard to making decisions, and necessarily so because there's a lot going on in operations. It's really important at the end of the year to come back and sit down and run these numbers in your operation and with your PCA and look and see if you need to readjust your program at all, or if you had great success and you want to stay with a particular program. So the example scenario A here, let's say, for example, there was no sanitation input, no financial investment, no additional sanitation done for whatever reason, economics, or it was a year where the orchard was very difficult to access because of weather conditions. In this case, let's say that 3 insecticides were applied, one against that May spray, quote, mummy spray, and a couple at whole split. And we chose to rotate the 3 main chemistries throughout the season. And in this case, we didn't have mating disruption as part of the program. So the cost per acre, was relatively low. And even without sanitation, we came in at 3% on the grade sheet. So if you look at the returns there and then the return minus cost, costs were nominal, but you didn't get down to the 2 or less than 2 or less than 1%. If you look at scenario B relative to the scenario A situation, so let's say we had some sanitation inputs, low inputs, maybe just an additional shake, and certainly if you look at the italics at the bottom of the model assumptions, we know that these sanitation estimates may be a little low as labor costs are driving up. But so let's say you did some sanitation, 2 insecticide sprays of the more selective variety, and added 2 sprays of Flowable to those. And so your costs increased, it looks fairly dramatic, but you were also able to cut your percent by 1/3. And what you're looking at is not only did your sanitation inputs, but your Flowable applications not only paid for themselves, but got you upside right to the tune of an additional $46 an acre versus scenario A. If we go to scenario C, very similar approach here. In this case, a little more input on sanitation. We added an additional mating disruption Flowable spray. Again, this 3 to 4 Flowable is where you might consider going to the puffer situation, which would cost slightly more than the 3 NOW Flowables at $29 per acre per application, but you're still upside right either way. So this input cost per acre starts to look fairly dramatic, but now you've got down to 1%. You're getting more of those quality bonuses. And again, your program paid for itself and then some. And if you look at, adding that 3rd Flowable and the sanitation from scenario B to C, $11 and some change per acre isn't necessarily a windfall. However, you're also saving potentially more insecticide inputs, able to rotate chemistries, minimize those, and hopefully mitigate resistance development, as well as protect, the beneficials in the environment, worker safety, all of those things that come along with benefits of using a mating disruption approach. And I kind of ran the same similar numbers for pistachio, and I don't think I need to go through these in detail, but essentially if you look at at no mating disruption versus adding a little bit, and we know that it can decrease our ultimate damage by 0.5% or so, and that's actually less than what's shown here by going from 1.6 to 1.0%. But your addition of flowable here, cutting your damage fairly decently, getting you close to that quality bonus. Again, upside right, and it paid for itself. And then the situation with adding additional flowable and sanitation inputs is shown on the bottom there, and that's when you start to really achieve those quality bonuses. And certainly, what I've shown here are positive situations where everything is functioning, our sanitation inputs are rewarded, we've done a really good job not only with our insecticide timings, but our flowable timings, and all of that to really get you return on your investment. But these are the types of considerations you should be looking at when you're deciding what part of the program you want to invest in. So, we talk dollars and cents a lot when it comes to ROI, or return on investment, from your overall pest management program. But there's a lot of those intangibles, or the less tangibles, as we might call them, when it comes to employing, really, honestly, when it comes to employing the whole suite of available IPM tactics. But let's talk a little bit about what mating disruption and what flowable less tangibles might be. So we know that sustained use of mating disruption, especially as Greg kind of notes, the broader the better. So, these neighborhood or area-wide approaches can really drive populations down with sustained use. So the snapshots that I just gave you are, single season snapshots of return on investment. Well, if you're using mating disruption season after season, you are driving down resident populations. If it's area-wide, you're driving down landscape level populations. And so you can think of that kind of amortization over the years of these compounded benefits. In addition, we've got these ideas of sustainability goals, whether they're more personal or individual to your operation sustainability goals of reducing conventional chemical inputs or extending the life use of the insecticides that are available. Our commodity and marketing boards have a lot of outlined sustainability goals, the Almond board's 2025 goals. No shortage of regulatory impacts kind of in play as well. And then there's marketing and PR. It seems like every time we turn around, there's a new sticker on the produce at the market. So there are some sustainability certifications and branding available to show that you're very effectively using, IPM or IPM-based approach. And this is not to say organic versus conventional, but these more sustainability certifications. And more recently, we've been hearing more about the potential financial incentives. So, for example, the NRCS programs where you can get some financial incentives for using things like mating disruption within a broad IPM program. And this is all in addition to the things that Greg mentioned in his portion, where we talk about environmental safety, worker safety, human health, the fact that mating disruptants have no non-target impacts. They protect our beneficials, so we're not going out and blowing up our thrips populations and having to spray more for spider mites. The resistance management conversation is one that we could talk for a long time on, but it's real. Resistance to pyrethroids is very real. We really have primary other chemistries that with sustained use year after year after year, resistance is a distinct possibility. And that, I'll go now to just where you can find a lot of the product information. There's a link here on your slide in the follow-up email that you'll get as an attendee. These will be provided as well, and they're right on our website. So you've got the data sheets, deployment guides, compatibility guides. I know there's some questions about that we'll answer. Product label, information about monitoring, all of that is available. And I will toss back over to Joan for a little bit of information before we head to answering some of the questions that have come in.
Thank you so much, Emily and Greg. As I mentioned earlier, we have that dedicated California-based sales and tech team. These are those folks, and we'll be sharing their contact information in this presentation as a follow-up. So we hope that you'll reach out to them. And then you're also, of course, welcome to reach out to our main telephone line and email in case you're not quite sure the right person to contact. And we also just wanted to mention that in that follow-up, we'll be boosting the audio. We've heard from a few participants that it's been a bit hard to hear, so we'll be making that correction in the version that's sent out following the presentation. And with that, I will pass it over to Robin, who will be moderating the Q&A session with Emily, Greg, and Mondo Perez.
All right, well, thank you, Joan. And yes, we apologize for the audio, but we'll make sure that we can boost that up a little bit for you all to hear in the recording. And we will also probably add just a couple minutes to the webinar. We want to respect your time, but there's been a lot of questions. So the first question actually is for Mondo, and it's, are there any tank mix partners that I should avoid, for example, NR415 oil?
Okay, that's a great question. Like Greg was mentioning, our Flowable product is tank mixable with common agrochemicals. We do want to avoid oils, and so example, 415 oil and mineral oils. But we regularly conduct compatibility testing, and to date, we have tested over 40, we have tested many active ingredients for compatibility, which are listed in our compatibility guide, so you can reach out to anybody from Suterra and ask for that.
Okay, thank you. We'll move on to Emily for our next question, which is any research on using puffers for season-long, any research on using puffers seasonally long and adding sprayable pheromone at key times and no conventional chemicals?
As far as internal trial data, we don't have internal trial data looking at this. We do have some anecdotal evidence that growers are successfully doing this in their fields. In addition, there is likely academic research that's looking at a variety of use patterns, but certainly having having puffers in the environment is going to provide you that level of disruption, of mating disruption that we've seen is effective in nearly all situations where we've looked at it in that 50% or so average damage reduction. But in those situations, particularly when you look at those numbers that I presented where the population level, when we go into those third and fourth flights, are really, really high. And in those situations, we sometimes do see a little bit of breakthrough with mating disruption. I tend to liken that to, I think of the normal beach every other day of the year and then the beach at spring break where just by happenstance you're going to run into a mating partner if you're a moth in the environment. So those really high levels may be served well by adding some flowable at that period of the season. But as far as data, we're constantly researching different use patterns and hope to have that data soon.
Okay. Another question for you, Emily, is why an increase in acreage in the three major nuts? I think they're referring to this, some of the slides in the beginning.
Right. I'll hypothesize what I think, and I don't know for sure, but certainly there used to be a significant amount more of cotton up through the Central Valley and various field row and veg crops, and those have given way a lot to almond and pistachio and things like that. So the marketing boards would have a better answer. The other potential answer to that is as we've developed additional rootstocks and things, we're able to successfully grow these tree nut crops on ground that was probably less ideal in years past with the different rootstocks that we had available. So for example, in the Sacramento Valley, we're seeing more walnuts push into old rice ground where before that was not necessarily a successful approach, but it can be done now. So that's probably another factor.
Okay, that's a great, very nice detailed explanation. Thank you. Joan, there's a question for you, which is about row crops. Do you have a product that's used on row crops in the Midwest, for example, canola?
Yeah, we have products for beet armyworm, tomato pinworm, and diamondback moth. But I would encourage the individual that asked that question to reach out to us because we would love to engage in a broader conversation about what their pest management issues are.
Okay. Okay, I think this is back to Emily. As you mentioned, the product is not an insecticide. We can use it on any crop with problems. So a little more of a general question.
So yeah,
I
think Greg started to address that. If you look at the label, it specifically calls out tree nuts, figs. I'm trying to think. I looked at it when that question first came, and states, you know, any crop where navel orangeworm is a problem. So short answer is make sure you're working with your PCA, make sure it's labeled appropriately. But yes, it's not limited to just almond, walnut, pistachio.
Okay. Okay, now we're back to Mondo. Is it better to apply Flowables by air, like plane or helicopter, since the material reaches the top of the canopies of mature orchards, as opposed to the type of coverage we would get via air blast sprayer? They understand that now primarily flies around over the tops of the trees. Are you able to answer that? Mondo, are you on mute? It might be. You might possibly be on mute.
I'll take that one, Robin. I'll stay
okay.
on that. So yes, so because the pheromones, the microcaps, do not actually have to come in contact with the insect in any way, flying it on is a great alternative if you've got irrigation going on. If you've got reasons that you can't get a spray rig through an orchard, flying it on is a very valid, very a good way of getting this out there. Will you get better coverage, one or the other? I think Joel Siegel has addressed that a little bit early in the spring when we were all still allowed to meet. And I think he's been finding that he gets great results either way.
Okay. All right, good. I'm just going through, we're getting so many questions in here. Emily, are there growers that use Flowable in addition to other mating disruptions like aerosols or dispensers?
Yeah, I think that was similar to the earlier question about having a puffer and then adding some Flowable in addition. And so yes, there are. Again, it goes back to, you know, what's your situation? How much pressure are you under in your operation to justify the cost of, you know, whichever additional tactics, and how much do you want to see your pest population come down? But yes, they're using combinations of. I will mention, although from a practical standpoint, the maximum grams per acre of AI of the pheromone is incredibly high, that when you're thinking about max number of applications or grams AI, it's combined from any material that you're going to use with pheromone, but it's got a huge maximum rate. So if you wanted to, you could put puffers and dispensers and come through with Flowable 3 or 4 times a year. But again, you know, that's a situation where it's probably not going to be terribly cost effective, and you might want to look at what else is going on maybe with your sanitation program or what's going on in the neighbor's block if you need to add, you know, all of the above year after year.
Okay. All right. Well, great. I think we're going to have to wrap up. Our time has gone fast. And I want to thank everyone for attending the webinar. And I guess if we didn't get to your question, the folks from Suterra will follow up with you individually, your questions associated with your email. So they'll be happy to answer anything after the webinar. As a reminder, an on-demand version of the webinar is going to be archived in just the next couple of hours, and it'll be available at the same link you used to register for this one today. And you can also find the link at growingproduce.com/webinars. So I want to thank the speakers again. They did a fantastic job. And thank you to Suterra for making this webinar possible. Have a great day.